Hi guys, this is Mr. Hurley and this is the second electronics tutorial. This is just going to be a real quick one, and it's just to let you guys know about the components which are resistors. In our last lesson we learned about the three characteristics of electricity: voltage, which is the pushing force, which is supplied by the battery; the current, which is the flow of electrons, or the flow of the electricity; and resistance, which is how much the circuit is resisting the flow of the current. Now we can control the resistance in a current very easily by using a component called a resistor. So let's have a look at some resistors on the website page. Here's the lesson on Electronics 102 resistors, and here's a little photo of the type of resistors that are in our packs. They're metal film resistors. Resistors come in all sorts of shapes and sizes, but these are a very common one. Right, so the way that the resistance value on the resistors is marked is by a color code. We measure resistance in ohms, so we use this color code to see what resistance value is on the resistor. So a resistor can have 4, 5 or 6 color bands. The ones in our kits are all 5 color band resistors. And the bands go like this. We've got the first 3 colors will be the 3 digits, and then the 4th band will be the multiplier. So we take our number from our 3 digits and we times it by the number according to the color of this band. And then our 5th one is our tolerance. That means nothing's perfect when things are manufactured, so every resistor is going to be plus or minus a certain amount from what its indicator value is. So if we had, let's say, a 100 ohm resistor and its tolerance was 1%, that means it could be either 1% greater or smaller than the actual value. So it could be, in reality, somewhere between 99 and 101 ohms. But that's pretty close. Okay, now if we had a 6-band resistor like this one, the last band would be this temperature coefficient over here. We really don't need to worry about that. That's just for when you're getting into seriously complicated and really electronics that need a very high level of temperature accuracy. And if it's got one less band, if it's only 4 bands, then as you can see from the diagram here, only the first 2 bands go into the number column, and then the next one goes over into the multiplier, and then we've got our tolerance band. So 4 bands equals 2 numbers, multiplier, and tolerance. 5 bands, 3 numbers, multiplier, tolerance. 6 bands, same as a 5 band plus the temperature one as well. So here I've got an example. Let's say we have a resistor with the colors green, brown, black, brown, brown. So the first 3 numbers are green, which is 5, brown, which is 1, black, which is 0, so that's 510. Then the multiplier is brown, so we multiply that answer by 10. So 510 becomes 5100, and we can call that 5.1 K. K would be kilo, 5.1 kilo ohms, or 5100 ohms. And then the last band, brown, is our tolerance band, which is 1%. All of the resistors in the metal film resistors in your kit will all be a brown 1% tolerance band. They're pretty high tolerance, these metal film resistors. Other resistors might be a bigger tolerance value, but they might be able to handle more current. It sort of runs a bit like that. Okay, now there's nothing about the color band that really specifically tells you which way around to read it. I did have a bit of an in-depth look into the resistors in these kits and had a look online and things. Some websites said things about, this first one will be thicker, or there'll be a gap on one side or the other. But I had a really close look at all the resistors in our kits, and there's really nothing like that to indicate which way around they go. So there's a couple of little clues we can follow. You might notice that in the 3D printer's ready. You might notice that in the tolerance band, there's a couple of colors missing. So there's no black, there's no orange. Sorry, that'd be orange and yellow, and there's no grey and there's no white. Okay, so if one of the bands on one of the sides is one of those colors, then you know that that's going to be the first leading number because it's not a viable option for the tolerance band. Okay. Oh no, sorry, I was looking at the multiplier band. So if there's a black or an orange or a yellow or a white, okay, a grey, we can have a grey in tolerance band. Okay, so and then the other clue you might find is that I've given an example here. What if we had a resistor that was brown, red, black, black, brown? That starts and finishes with brown, so the tolerance band could be either side. So if you read it one way, it could be 120 ohms, 1%, or if you read it the other way, it could be 10,000 ohms, 1% tolerance. Okay. A thing to remember is that resistance values, especially for small values, will generally be numbers like 110, 220, 330, things like that. 120 ohms is not a value that I've seen. They tend to go more along those numbers. So that resistor is more likely to be a 10,000 ohm resistor or 10k ohm. It's just another way to say 10,000, 10 kilo ohm, 10k ohm. Okay. Now that's the tolerance band. We talked about that. And the way that I usually measure resistance on resistors is to just grab out a multimeter. Unfortunately, your packs don't come with a multimeter. They wouldn't fit. It's not something that you're really going to need for our lessons doing our Arduino tutorials, but it's just a handy thing to have for going that next step if you want to do your own prototyping, coming up with your own projects, especially when you start getting into soldering. If you want to check that you soldered something correctly, that the electricity is conducting through. There's a lot of really good testing things you can do with a multimeter. I would suggest if you get through all this lesson series with me, and you want to start designing your own projects, the first thing you're going to want is a multimeter, because what you can do is just hook up the multimeter to those two probes there and set it to resistance, and it'll just tell you exactly what the resistance of the resistor is. Okay, so I've got a couple of practice examples. These are actually all of the resistors from your kit. I've written down the values, and I tested them with my multimeter to make absolutely sure they're the right way around. So what you might like to do is to go through and figure out all the values of all these resistors. Just get my set out. Okay, here they are, and see how they got you can't see the resistors because of the blue screen, but on these cardboard little tabs at the top here, once you figure them out and check your answers, you can click this link to see my answers. Then you might like to go ahead and write the value onto each cardboard little strip on the resistors. That way you won't have to go tediously through the color chart every time. If you want to just grab a resistor, just pull it out there and it'll be written on. Okay. Then once they're all been pulled off and you've got a little pile of resistors all in the punnet inside your box, then you'll have to start getting out those color codes. But it'll be a good way to get started. So I'll go through just the first one as an example again. So we've got brown, black, 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 brown. So that one could go either way. It's like a palindrome. It's the same no matter which way you read it. So brown, black, 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 brown. Let's go to our diagram, and your kit comes with a little card with the diagram on it, so you can use that. It's a nice little handy thing to have. So we have brown, 1, black, black, that was 3 blacks, wasn't it? Let me just double check that. Yep, 3 blacks and then brown either side. So brown 1, 0, 0. Our multiplier is 1, and so that should be 100, and brown 1%. So 100 ohms, 1% tolerance. So let's check my answer. I'm just going to look at the first one. 100 ohms. Very good. Okay. So go through and figure out all the answers for all these ones. Try to work them all out first before looking at the answers, and then once you've checked them on the answers, go ahead and write them down on each of your resistor on the cardboard tab, and that will make things easier for moving on to actual projects. Thanks guys, have fun with that, and I'll catch you next time.